I installed an open source intelligence console this week. A photorealistic 3D globe, live aircraft, live earthquakes, public cameras, voice control. The install took under an hour. Then I spent the rest of the day finding out that almost nothing it produced was legal for me to publish. That second part is the story. Here is the shape of it. The software is free and openly licensed. The data inside it is not. And the gap between those two facts is where every real decision lives. 4 of this app's data sources are non-commercial: the submarine cables, the flight positions, the news headlines, and later I found a fourth, the free tier of the 3D tiling service. 2 of them are switched on before you touch a single setting. The flight layer in particular runs anonymously with no key, so nothing ever asks whether you agreed to anything. If you run a business, that matters, because the app ships a clean view mode and a recording mode built specifically for capturing footage. I ran this against a written plan and 5 of its steps were wrong. The best one skipped the development dependencies to save 200 megabytes. Reasonable advice, except that in this project the web server itself lives in that bucket. Following it would have produced an application that installs perfectly and cannot start. I caught it by reading the launch script before running it, which is the only reason this is a footnote instead of an afternoon. This one cost me 2 keys. The Mac's own secret store, when you type a value into its prompt, silently keeps the first 228 bytes and throws the rest away. No warning, no error. The key looks right. It has the right prefix, the right shape, no stray whitespace, and then the service rejects it with an unauthorized error that tells you nothing. I destroyed a perfectly good key, had a replacement issued, and destroyed that one the same way before I thought to compare the stored length against the clipboard. Map data took 33 seconds to load, and I assumed the source was slow. It was not. 3 of the 4 mirrors were failing outright. The one that worked answered in 1.2 seconds, but it sat third in the list, and the proxy tries them in order. Worse, the mirror in second place takes 35 seconds just to return an error. Almost every cold request paid that toll before it ever reached the one that worked. Reordering helped, but not enough, and the reason is interesting. The 2 healthy endpoints sit behind one load balancer and take turns failing. Sometimes the first one answers in 2 seconds and the second time's out. An hour later, it is reversed. No fixed ordering can win a coin flip. So instead of queuing them, I race the top 2 in parallel and abort the loser the moment either one answers. 33 seconds became 2 to 4. I capped the race at 2 deliberately because this is a free volunteer service and every extra racer is duplicated load on someone else's donated hardware. I tried to draw a driving route across 4 states and refused. My first theory was a wording default. My second was a distance limit. Both are genuine constraints in that code. Neither was the problem. The real cause was a safety gate that rejects any place resolving further from your current view than a certain radius. A sensible guard against bad matches. Zoomed into a city. That radius collapses to 50 kilometers, so every waypoint hundreds of kilometers away was thrown out before routing even started, and the resolver had been printing that exact reason with both distances to the browser console the entire time. 2 wrong answers while the right one sat on red. Real quick, I have been wrong 3 times this week. Called a rate limit a spam filter, archived the wrong file, told someone a token was leaked when it was not. The difference is that I check every time. That is the whole phase 0 checklist. 3, linked below. The school group is where we compare notes. Then I found the thing that changes what this tool is for. What ships as a closed circuit camera layer is not a camera list at all. It is a geo-anchored projection registry. Every record carries a video address plus a complete pose, position, editing, pitch, field of view, range, height above ground, pointed at your own aerial footage, and it projects that footage into the photorealistic 3D scene at the exact position and bearing it was shot from. No code, 1 configuration file. I proved the whole path end to end on a test server, and the video streams correctly with proper seek support. The limits are real and worth stating plainly. The media is fetched by the server, so it needs an actual video file at a real address. A video page will not do. And the pose is clamped to a street camera model. I fed it a straight down aerial shot, negative 90 degrees of pitch, a narrow lens, 120 meter range. It came back as negative 55 degrees, a wider lens, and 220 meters. Oblique aerial footage projects convincingly. Straight down footage simply cannot be expressed, and no setting gets around it. I looked at whether to pay for the hosted 3D tiling service. In this application, a paid token unlocks exactly 2 extra base maps. The free tier is non-commercial, so for a business, the real entry price is $149 a month. Then I opened the type definitions already sitting on disk and found these two functions side by side. One loads a tile set from a hosted account, the other loads a tile set from any address at all. Your own aerial survey on storage you already pay for needs no account and no subscription. Same small code change either way. The only actual choice is where the bytes live. And here's the sentence that decides whether any of this is a product or a private toy. The mapping platform's terms say its content may not be cached, stored, or rehosted. A screen recording of that globe uploaded to a video platform is stored and rehosted content. I am not a lawyer, and I am not telling you what those terms permit. I am telling you that the project's own documentation fences off precisely the artifact you would be making, and that this needs answering before you build a capture workflow, not after. Which is exactly why owning your own imagery stops being a nice idea and starts being the whole strategy. What I built in the end was small and specific. The app already fetched road data, but only inside a traffic layer that colors roads by flow. And with no traffic key configured, that flow is simulated. For anyone publishing, a screenshot of invented traffic labeled as traffic is the problem, not the feature. So I wrote a layer that draws major roads only and claims nothing about conditions. 5,929 segments over one city. I also added 3 keyboard shortcuts, including one to point the camera north, which the app could not do without throwing your view away. The install took under an hour. The audit took the rest of the day. And the audit is the part that produced anything worth having. Do you take one thing from this? The hard problem with a capable free tool is almost never getting it running. It is working out what you are allowed to do with what comes out. And that answer is hiding in license files, in sources that are on before you choose them, and in a console log nobody read. If this was useful, subscribe to the channel and hit like, it genuinely helps. Thanks for watching.